All right, here's a quick recap of Chapter 3, just to help you with your quiz. If you're watching this video, hopefully you're going to take the quiz soon. We started Chapter 3 with quadratic equations with a little doodle notes here, but just it's 5 ways, 5 methods of solving quadratics. So we learned 5 different ways, and you'll see all of them on the quiz, or as many as you need. Factoring is listed first. It's probably the most common. When you see a quadratic means you've got a little x squared. Okay, so when you see a quadratic, you'd like to break it down so that the x squared is gone, and we often do that with an x and putting the last number on top and the middle number on the bottom, and asking ourselves what multiplies to get this last number of 12 and adds up to the middle number of -7. -4 times -3 is 12, and -4 plus -3 is -7. So these were the two factors. -4 and -3 are the two factors. But what's going to make those factors equal 0 is the question, because it equals 0. And that's going to be a +3 and a +4. So 3 and 4 were your answers. We also had a square root method where you could square root both sides. You might see it where there's a parenthesis squared, or you might see it where it's just an x squared or something. You might have some that are like 2x squared. Oops, like 2x squared equals 18 or equals 16. No, let's go 14. And they want you to solve for x, so you could divide by 2 to get x squared equals 7. And once you get the x squared by itself, you would square root both sides. And x would equal a plus or a minus radical 7. You can't break down radical 7. And when you square root both sides, you need your plus and minus. So that's a square root method. You could have a parenthesis squared where you could square root both sides, or just an x squared where you square root both sides. You're just trying to get the x by itself. Completing the square starts with a trinomial, and then we break it down into a perfect square like this square root method. But to do that, the middle term had to be even. When we divide that by 2, because if it's not even, it'll be a fraction. We don't want a fraction. Because the first step is to take it, divide it by 2, get -3, and that's going to be your parenthesis squared. Whatever you get when you divide by 2 is going to be in your parenthesis. Then you square it. -3 squared is 9. That's what you're going to be adding to both sides, okay, to keep it equal. And then you square root both sides, do your plus and minus because you square rooted, and then 3 plus 1 and then 3 minus 1 would be your answers there. That one's not as safe because that one, you might have an odd number. You definitely don't want to use that. Factoring doesn't always work. But if the answers, here's a hint, if the answers are whole numbers on a multiple choice question, then factoring will work. So if you see whole numbers or fractions, then factoring is good. Use it. If you see your answers as decimals, like these radicals here, or just decimal values, then you're probably going to need quadratic formula. And we went over that. You can watch the video again on that. That would be here your opposite of b plus or minus your big square root, b squared minus 4ac all over 2a. And you take a, you take b, you take c. Make sure you take the sign with it. -6 is your b. And you plug everything in and you solve it. And then you reduce it if you can. The last way was looking for the graphs. If you just type this into Desmos, which we did a lot of times, you get a U-shaped curve because it's quadratic. Wherever it touches the x-axis are your solutions. That's your solutions. The line down the middle that cuts it in half is called the axis of symmetry. The very bottom is called the vertex, vertex. And this vertex, in this case, is a minimum point because it's the lowest point. We said the lowest point's a minimum. The high, if it was flipped upside down, if that was like a negative x squared and it was flipped upside down, then that vertex would be a maximum point. It would be the highest point. So there is no maximum on here because these go up forever, but there is a minimum. It cannot be lower than this right there. So those are 5 different methods. You can look at some examples there. Then we went to 3.2, and we started to put all these into practice. So here we did square roots. Okay, so first we learned about all of them, then we did square roots, but we did something else in 3.2 is what we learned what an imaginary number was. We learned what radical -1 means. Radical -1 means I, and if you square both sides, then the square root and the square will cancel out, and -1 is going to equal I squared. So that's why I put that there. So radical -25, you could cut into two pieces. Radical 25 times radical -1. Radical 25 comes out as your 5, and radical -1 is your I. So that would be your first one, radical 81, radical -1, so 9 and then I, 9I. And then we actually broke this one down into 16 times 2, because 16 is the biggest perfect square we can pull out of 32. Square root of 16 is 4. Radical 2 doesn't come out, but radical -1 comes out as I. Then we talked about combining like terms. I's can go together. 2I and 7I is 9I, just like an X. 3 and 5 is 8. 6 and 4 is 6 minus 4. You got to distribute the negative. Be careful on that. Negatives have to be distributed. 6 minus 4 was the 2. 5I minus 3I was the 2I. Then we learned about distributing i's so that when we multiplied I and I together, we got I squared. But we know that I squared equals -1. So anytime you see I squared, you can take it out and put in -1. And then you could solve it, make it smaller. And then we also practiced our FOIL. First terms, outside terms, inside terms, last terms. First terms would be 2 times 3 is 6. Outside terms, 2 times I. Inside terms, 3 times -I would be -3I. And then last terms, -I times +I would be -I squared. But you can take I squared out and put in a -1, but you can't, you got to leave the negative. Negative's going to come down in the answer. So that when you put a -1 in there, you're actually going to have a negative, which changes to a positive. And so you're going to get 6 plus 1, which is 7, and then you got your -I. So that's FOIL. So we had imaginary numbers. Finding the zeros just means to set it equal to 0 and solve it. That was 3.2, 3.3. We talked about completing the square. We just went over that on the 5 methods. Only do the completing the square if the middle term is even. If it's even, then you get a nice number that you can square and you know what to add to both sides. But you can go back and watch the video on 3.3 if you want to know how to do any of those for completing the square. Then we moved down to 3.4 and we did a bunch of quadratic formulas. Now there's not much to that one. You're just plugging in the numbers and simplifying it. So you just had to find out what A, B, and C was. So number 5 here, you got to make sure your x squared is always positive. So I changed all of my signs, and then you can get your A, B, and C. So your 3 was A, your -5 was B, and your +4. After you change the signs, we would add 4 to both sides, and you'd have a +4 because you want it equal to 0. You can't get A, B, and C unless you have it equal to 0. To solve quadratics, has to equal 0. Once you get it equal to 0, so if I added 7x to both sides, now I can figure out what A and B and C are, and I can plug it into my quadratic formula. So that was 3.4. Then we did 3.5 and 3.6, where we were just graphing some systems. We put them on a graph. We would see where they intersected. So we actually did these on a graph. We graphed the linear equation, we graphed the quadratic equation because that's an x squared, and we saw that these were the two places that they touched. We actually drew that on a graph. And we just did it on Desmos. You have Desmos available, so when you're taking the quiz, I would just put those into Desmos and see where they touch. Then we could actually take out y and we could actually plug it in and solve it. So there's a substitution method because it's already got y by itself. So where you see y, just put in x minus 4, and then you can solve for x. And then we could also use elimination, and I showed you how to do elimination on video for yesterday. And then inequalities, we were just graphing and shading to see if it's a greater than, an equal to, or a less than, an equal to. Greater than or equal to, it's going to be a solid line shaded inside above. Less than or equal to, shaded outside below. Solid line. If it was just less than, it would be a dotted line. Solid line because it actually includes the graph. So we had a couple of those where we were seeing the shading on the graphs. And that was it for chapter 3. So good luck on your quiz. You can go back and watch any of the other videos if you need more assistance.